Okay, now we've got the inserts in, we've resized them, we've honed them, all ready to go. We're now down to cut the valve seats. We've just done a quick check, and I was just talking to Mike and showing, we just dropped some valves in there, and the alignment of the valve to the seat seems to be exceptionally good, which is what I would have expected to happen. In other words, we've actually bored the guide to suit the seat, as opposed when we put a guide in, it can wander around and shove off to left, right, backwards and forwards. And every time I've done one, you always find that when you put the valve in, you can always already see light coming underneath between the valve face and the valve seat. We just dropped an exhaust in before, and it looked as if it was almost a total seal, apart from being a bit too wide. So now we're going to do the cutting of the valve seats. If I was at home on my own, where I normally do this, I've got a 30 Pro, which is, for those that are a bit familiar, is a big machine. It's about the length of this, or a bit longer than this bench. It's got air drive head onto it, and it has a cutter that sits on the air drive head that has all either 3 angles cut onto this machine into the cutter, or 2 angles, whatever you want. They're a little bit slow to use, but they do an exceptionally good job, and obviously most of the race people worldwide use a very similar pros. Surdy is a French company, but there are other companies. Everybody in the world makes this same version of the machine. Because I'm not at home, I'm down here at Mike's place today, I've brought what we call old technology. It still works very well. Repco in Australia, and that's, a few of you would be aware, Repco is not just the spare parts people. They used to manufacture machine tools, a lot of engine reconditioning. They don't exist anymore in Australia. But these are what we call a vibro stone system. So it's still very applicable, still work well. We can still buy these stones. There are other people in the world that do make the stones. So we can buy stones to still fit these machines, and they're very quick, very accurate. So we just put this into here with a stone on the end of it. You have a drill with a little drive unit at the end of it. You put it on there, like so. And then obviously we would need a little bit faster than that, but we turn that and it actually grinds the seat. But before we do that, we need to make sure the stones are nice and parallel on the front. So these are 45 seats, so we've got to make sure that that is been, you can see it's a bit dark on there. I hope you can. It's been used before, so I'm looking at this and I can probably see a fraction of a indent in the stone. So this is called a stone dresser. So we'll just quickly show you what happens on one of these stone dressers. There's a little diamond head cutter in here, sits on this, and we can adjust it to suit any angle we want. So we'll just set this up till it just about touches, around about there. We'll set this going. I'm working a little bit back to front on my hand. Just double checking, make sure it's on 45 degrees, yes. And just check this one to make sure it is. Yep. As you can see, it's not quite concentric, so we need to keep trimming it to make sure it's nice and dead and square. So we're nearly there. As you can see, nice clean 45 degree freshly dressed stones. So you wouldn't do this for every time you did a valve, but after a valve job you would check it to see it's parallel, or you should at least run it over the machine. So now we'll put the mandrel, which is aligns it to the guide, back into here. Do up the little locking screw. pop that out of the road. It's a little bit, this one we've noticed is a little bit tight, just might need a little bit of oil on it.
Bill, you were telling me before that you didn't want to get oil on the stone itself.
Yeah, that's correct. Obviously, these stones have got to be dry. That's how they work. There's a little clutch in here that if we set it right with enough load on, the actual stone, as it's going around, actually vibrates, because that's what they're called, vibrating, a vibrate stone cutting system. You don't have to vibrate them, but they do work a little bit better as a vibrator type stone. So we'll sit that in there, get our drill on top. And you could hear it, hopefully you can, hear it vibrating on the stone. And if we, I don't know whether Mike can see, or I'll get it in a position. We've only lightly cut that at the moment, and you can see it nice and shiny all the way around. We've just done the lightest of cut. So we really don't need to cut that much deeper than that. That means that the insert has gone in dead parallel to the valve insert, so we're not wasting a lot of insert by misaligning guides and everything else to it. So we now need to, after this, we'll need to put a valve in with a bit of what we call bearing blue or Prussian blue, or something else that leaves a mark on it. You can physically see what the width of the valve seat is compared with the valve, because if it's, I'm looking at that, it's an exceptionally wide valve seat. Normally, depending on the engines, some engines require maybe in thou, maybe a 30 thou wide seat, others need 20 thou. Guzzis around I normally run about a 25 to 30 thou, 50 thou wide on the valve seats, or maybe a little bit less. So that's the contact between the valve seat and the valve. We can run thinner, and there is lots of reasons why you would run thicker or thinner. The thicker the seat, the better the heat dissipation across, but the wider the contact, the more likely if the bits of carbon or something building up will get stuck, jammed between the valve seat and the insert. So then that can cause it to stay jammed open. So valve seat's contact area needs to be reasonably small, but obviously not 10 thou wide or something like that. So that's one inlet just been lightly cut. So that's how quick and easy. It's much quicker than, as I said, a SERDI system. And a lot of the older machine shops in Australia, and I think the rest of the world used to use them. SERDI have taken over now and use their machines everywhere, but I think some of the shops still use this same system where they think it's applicable and everything else. So I've got two of these set up. So one is on the exhaust seat and the other one is on an inlet. So we'll just quickly do the exhaust one. I'm just looking at this and going, hopefully that's 45 I started with, but it's no big problem. Mike's been on to me saying, I hope you make a mistake, it looks much better for you people. So we'll just grab this valve. Yeah, definitely 45. Just means that the seat is probably a little bit more worn than I thought it was going to be. And you can probably hear that noise, that's the vibration side of it. Looking good, it's coming good. Nearly got it. It's just one little spot that's needs to be cut a bit more. it's just a little pitted in a couple of spots, so we need a little bit more on it. Yep, looking very good. I'll just give that a very light run again, but this time very little pressure, so just polishes it. Pretty good. So now that we've cut the valve seats at 45 degree, we've got to find out where the seat sits in the valve. You just can't have a seat sitting anywhere in the valve. So the theory is you should have the valve seat in the head sitting in roughly about the middle of the valve, say 40 thou wide or something like that, up to 50, somewhere down to 30, just depends on the manufacturer and what you're trying to achieve. So to do that, we need to put bearing blue or some other similar material that leaves some sort of a mark on it. So we put a little bit of bearing blue or Prussian blue on the valve seat, on the valve face, drop him into the exhaust valve, give it a bit of a tap down or a twist so we can transfer some of that bearing blue onto the valve seat. Then taking it out, we can have a look to see if we can see any mark on here. Now, sometimes you can pick it up easy. If you've had to put quite a lot of bearing blue on it, it's not so easy. So we need to put the bearing blue on there first, off of this. You wipe this free, so now we've got the total the valve seat. I don't know where you can see on that there. The blue on it is the full width of the seat. So now I'm going to try and transfer some of that blue back on the valve to try and establish just how wide the seat is and actually where it's sitting on the valve. Is it sitting all towards the top end of it or the bottom edge of it? So having a look at this now, and I don't know whether this shows up very well in this light, but at the moment it looks like we've got a valve seat somewhere near the middle that also runs up towards the top. So that means it's not quite concentric, in other words, square to it. It's a little bit, the seat, in other words, if the valve was there, the seat's exaggerated, sitting at an angle like that. So we now need to trim the top edge of the seat to bring it down to centralise it. So depending on what engine you're doing and what you're trying to do, some people use 25 degrees on the top, some use 30 degree top seat to lower it down. There are lots of other options in it. As I said, a race engine, lots of people do some weird and wonderful angles. Sometimes it can be advantage for performance orientated, but this is a normal street motorcycle, so we're just staying with between either 25 to 30 is the most common ones to use. I tend to use 25 a little bit on the exhaust, up to 30 and 30 on the end for a top cut, and then the throat can be 60 and 75 or 75, things like that. So we can shift the seat around. So this one needs to be just moved down a bit. So changing the seat cutters, I've got what we call new wave valve seat cutters here, which is a 30 degree cutter. So we'll just drop out one of these mandrels. Because we need to reduce the width of this seat. So that goes in there. Looking good. So, using just a hand drive, two or three turns, lift it out and have a look to see how it's going. Now, as I explained to you before, on the valve seat I said to you that the actual valve seat was sitting at a bit of a funny angle to the valve angle. In other words, instead of being at 45, it's actually cocked. So we've got a valve seat that's sitting very slightly like that, and I've just done the top cut, and it's showing on one side of it it's cutting a lot, the other side it's not. So it's exactly as I thought it was going to be. So we now need to keep cutting to true it up a little bit, and it'll help reduce the width of that valve seat. So now, again with a bit of bearing blue, back on there, drop the valve in, I'm starting to see a bit of a guide here. It looks like it might be sitting reasonably well on the top, so let's transfer back on the valve strictly off the seat. And we're close to what we want. It's just showing about 1 millimetre clear of the top on one side, a little bit closer, so it actually needs just a fraction more cut off it. Starting to show not a bad sign on that one, but to get a really accurate reading we now need to transfer the blue from the seat back onto a valve. And it's looking quite good. We're about 1 millimetre clear off the top, or a little bit more, but it is still too wide. Looking down here, it's probably 100th thou wide, the seat, maybe wider, so we've now got to trim it in on what we call the throat, so that's the inside edge. So again, now using this cutter, which this one is a 70-degree cutter. Sometimes it depends, engines use a 60-degree, sometimes you could use either a 60 and a 70, so put a double angle on it, which can be better for flow. But again, this is only for a street engine, so one single cut is more than adequate enough. So now we need to reduce these right down the bottom. As I said, this is old technology, so the new machines that cut all the valve seats, the 3 angles or the 4 angles in one head, are ultimately much quicker and a little more accurate, but there's nothing wrong with this, it still works. I think we're almost there, starting to look quite good. So we now have clearance on the bottom or the throat, but looking a little bit closely, it still probably needs a little bit more on the top, so I'm going to have to go back and do a slight. It's better to do this a bit slow, because if you remove it and you have to put it back on, you cannot put it back on. The only way you can put the material back on is recut the valve seat even further into the head, which sits the valve further in, and it creates lots of other problems, or we'll finish up having to replace the insert, which is, for us, is not an option today. So I can see without going any further, we've got this about where we want to, and I don't know whether you can see, or you can zoom in a little bit in this light, but you can see there's a little shiny bit in the middle, and so there's clearance on the top, and there's a little bit of clearance on the bottom. So we've got the valve seat in the middle, and it is exhaust, so we need a little bit wider valve seat because to get rid of the heat. And I'm happy with the width of the seat. So that's one exhaust valve seat done. So that's top cut, bottom or throat cut, and the valve seat itself. So we've got it back sitting in the middle of the valve. So we're getting now close to having to do the setup for the actual how far we've had to cut the valve seat. So we're talking about spring heights. We'll talk about that shortly.